There we go. Looks like we're all up and running. Hopefully you can hear me. Hopefully everybody's the mic sounds good. Everything sounds all right. I had to mess around with my audio settings the other day, but I think it actually sounds a little clearer. We're gonna find out. I'm gonna get a brandy new headset maybe for next week, or at least coming up soon. So hopefully it'll sound even clearer with the new one. But in any case, good morning. Hopefully you're having a fantastic day so far. Happy Thursday, May 14th. Today, what I would like to do with you is I would like to solve some rational equations. I have just 5 examples that I'd like to run through all 5 with you. I anticipate that'll take about 25 minutes, 5 minutes per problem, maybe less. It will, make up a little bit for the fact that you guys stayed a couple extra minutes last class, which I sincerely appreciate, by the way. So I'll let you off the hook a little bit early today. In any case, after today's class, there will be a progress assessment sent your way via email, just like there usually is on Thursday afternoon classes. That progress assessment will be 4 problems on solving rational equations. To submit it, just like you've submitted the others, make sure you do out your problems on paper, take a picture of your work, send it to me via email by just replying to the original one that gets sent out to you, and we'll all be happy. It will be due on Sunday night at 11:59 p.m. So do make sure that you get that done in time for Sunday night. That gives you all of Thursday afternoon, Friday, Saturday, and Sunday. Okay, so I think that's plenty of time to make sure you get that assessment done. Again, if there's any extenuating circumstances getting in the way of that, please just feel free to let me know. Last thing I want to point out to you again is make sure, did I say fill out the attendance form? I don't remember if I said that, but again, being first period, it is particularly important that you fill out that attendance form on Google Classroom. Okay, so fill out the attendance form. Make sure you have your microphones muted and webcams disabled. But if you do have anything to say, any questions, excuse me, please feel free to just speak up and let me know. Or if you're uncomfortable speaking up in voice, then feel free to type in the chat. That's fine too. All right, so let's dive into these examples so we can get you geared up for that progress assessment. Last class, we talked about solving rational equations. These are the notes I gave you last time. And what we essentially talked about was the fact that if we're looking to solve any of these rational equations, the first thing that we need to do is identify our domain restrictions. By taking the couple seconds to identify our domain restrictions right out of the gate, it helps a lot for when we can identify extraneous solutions later. If we didn't do that, it would be kind of a pain in the butt to go back and try to identify your extraneous solutions after the fact. Let's just identify those domain restrictions right away. That way it's quick, it's easy, it's already done. Then when we're actually going to try to solve these equations, the first thing I want to do is factor and simplify any denominators. Identify those domain restrictions because factoring helps you identify those domain restrictions. Find the least common denominator, or your LCD. Convert all terms to have that least common denominator. And then once all the denominators match, then we can just shift our attention to those numerators. So that's why it's important, and that's why it's nice for us to be able to find that LCD, because once we do, then we can just focus on the numerator. All right, so that's the deal. So let's get into, like I said, I have 5 examples to show you today. We'll see how long it takes. Again, I do want to emphasize that there will be a PA sent to you via email today. It is due Sunday night, so make sure you get that to me. Okay, it's only 4 problems, just like these. So let's do it. Starting with our first example here. And not surprisingly, just a little FYI, I did pick these examples purposefully to highlight things that may show up on that progress assessment. All right, so if you need a little refresher, feel free to either watch the video back or ask me or meet during my office hours or whatever. But, you got everything you need. I'm going to make sure you have everything you need, and let's get to it. How about something like this? We have x minus 3 over x squared minus 1 over 5x squared equals 1 over 5x. Okay? I want to solve that equation for x. First things first, let's factor if we can in the denominator. I look for a second. I notice no factoring, so that's good. Next thing, we can identify our domain restrictions. Here in this problem, you should be able to see that x could not be equal to 0, because if I plugged in 0, actually across the board, it would result in dividing by 0, which is very bad. So our domain restriction here would be that x cannot equal 0. Now that I identify that, I can find my least common denominator. Let's see. Looking at the constants, I need a factor of 5 to make those guys happy over there. I need a factor of x at least. And I need to bump that x actually up to x squared to accommodate this and accommodate this. So hopefully you see, by making the least common denominator 5x squared, that makes everybody happy. This is happy because I could multiply that by 5 to get here. This one's happy, it already matches 5x squared. And this one's happy because all I'd have to do is multiply by an additional x. Alrighty? Now that I have that, I can go ahead and convert all of my denominators. I would like them all to look like 5x squared. Right? I'd like them to all look like that. What do I need to multiply this by in order to get this? I need to multiply by 5. So I'm going to multiply by 5 to the x minus 3 that's already in the numerator in order to convert that fraction successfully. What do I need to multiply this by to get this? Nothing. Just leave it alone. What do I need to multiply this by to get this? An additional x. So I'm going to do 1 times x, which is x. Now that all your denominators match up, we can just shift our focus to looking at the numerators. In the numerator, we have a little distributing going on right here. I'm going to get 5x minus 15 minus 1 is equal to x. Just like that. And now this is turned into, notice the 5x minus 15. Notice this is now turned into just an Algebra 1 problem, right? We can combine the constants, combine the variables. I get 5x minus 16 is equal to x. Let's subtract the 5x over to the other side. You get negative 16 equals negative 4x. Divide by negative 4, you get x is 4. Okay. How do you know that that solution works out just fine? Well, we just take a 2-second look and say, does that match our domain restrictions? No, so we're happy. You could also, if you want to, it's a little excessive, but you certainly could take this value, plug it in, and see if this side of the equation equals that side of the equation, which it certainly should. But again, that's a little much. But certainly a thing you can do. Any questions about how that's done? That's our first example of 5 today. Feeling good about that? Let's keep going then. Let's keep going. How about problem number 2? Okay. Problem number 2 looks like this. We got 4x minus 1 over 2x equals 5, just a regular old 5 by itself, plus 15 over 6x. Okay. I want to try to solve that equation for x. Remember that what I mentioned last class, it came up in the very last example we looked at. When you have just a plain old number or variable by itself, like just a 5, or say it was like a 2x or something like that, just a random term by itself, it doesn't mean that it has no denominator, and it doesn't mean that it doesn't have to be considered when finding the least common denominator. It just means that we can re-express that as over 1. And if that helps you to visualize the fact that these 3 denominators are as such, this does have a denominator. The denominator is not 5. You don't have to factor the 5 in the least common denominator. Any whole number or variable can be written as itself divided by 1 or over 1. Okay? So if it's helpful to you to write it that way, I'd highly recommend it. Now that we've done that, we can go ahead and find our domain restrictions. There's no factoring to do, so we'll find our domain restrictions. Again, here I think the deal is that x cannot equal 0, because 0 times 2 would be 0, 0 times 6 would be 0, right? So that's the only thing that causes us issue. Notice we don't have to look in the numerator to find any domain restrictions. I forgot if I mentioned that last class. We're only looking at values of x that would cause the denominator to be 0. So a common student mistake that I see sometimes is in a problem like number 1, they'll say, oh, a domain restriction is x cannot equal 3 because 3 minus 3 would be 0. That certainly would be true if there were x minus 3 in the denominator, but being in the numerator, it's fine for the numerator to be 0. The numerator being 0, 0 divided by anything is 0. So that's just fine. It's when the denominator is 0, that's when we start running into bad news. All right, anyway, going forward from here, I now find my least common denominator. Least common denominator of 2 and 6, and 1 for that matter, is 6. Least common denominator of x and x is x. So let's convert everything to be out of that denominator and see what we need to adjust everything by. What do I need to do to this in order to make it look like this? I need to multiply by a 3. So I'm going to do the same on the numerator. I'm going to take what's already there and multiply by 3. What do I need to do to this to get it from here to here? I need to multiply by 6x. I'm going to take the 5 in the numerator and multiply it by the 6x. What do I need to multiply this by to get this? Nothing at all. I'm just going to leave it as the 15. Okay. Now that all my denominators match up, we can go ahead and just focus on the numerators. I'm going to do a little more distributing over here, just like the first example. It's going to give me 12x minus 3 is equal to 30x plus 15. Again, now this is just glorified Algebra 1. We can go ahead and subtract 15 to both sides. I'll also subtract 12x from both sides. That's just bringing all your variables to one side, bringing all your constants to the other side. That gives me negative 18 is equal to 18x. And so therefore, x would be negative 1. Okay. How do we know, by the way, that negative 1 is a valid solution? Well, we just take a look. Does it match our domain restrictions? Nope. So we're A-okay. Okay. Any questions about that? Luke asked a good question in chat. He said, how do you know or find all the domain restrictions? Again, we're just looking for the values of x that would make the denominator equal to 0. So I would say what value for x makes this denominator equal to 0? What value for x makes this denominator equal to 0? In both of these cases, that value is 0 itself, because 2 times 0 would be 0, and 6 times 0 would be 0. You can almost think of it as if you wanted to. If you couldn't picture that off the top of your head, you could say, well, for what value of x is 2x equal to 0, and when does 6x equal 0? And for both of those, it's x equals 0. So that would be your domain restriction. Okay, but it's just like. Oh, sorry. Go ahead.
Can you show us a scenario where it's not x isn't equal to 0?
Yes, that's exactly what's coming up soon. It's almost like you're predicting the problems coming up, Luke. Absolutely. Yeah, absolutely. Okay. Does that make sense, though? Okay, doke. Fantastic. All right, let's do a couple more. We got 3 more to go today. Okay. How about something like this? Third one I'd like to do with you. We got 5 over x minus 1 is equal to 1 over, let's do x squared minus x plus 3 over x. Okay. First thing with a problem like this, what do I need to do is I definitely need to do some factoring. Hopefully you see x squared. That should immediately draw your attention and be like, definitely some factoring going on. So with this value right here, I could take out a GCF. That greatest common factor is x. And I'll rewrite this as 5 over x minus 1 is equal to 1 over, take out the factor of x minus 1, plus 3 over x. So everybody see how we took out that greatest common factor? Now that I did that, I can find my domain restrictions. Here, what can x not be equal to? There's actually 2 problem values here. The first one actually is, ironically, 0, because if you notice, plugging in a 0 here would just result in 3 divided by 0. That's bad news, so I'd have to specify that x could not equal 0. But also in this particular problem, what would make this denominator equal to 0? It would be 1, right? Because 1 minus 1 would equal 0. So just like finding your vertical asymptotes when we did graphing, it's the same thought process. You're saying what value for x would make this piece equal to 0 and this piece equal to 0. And this piece is just both of them. Luke and everybody else, did that help clarify what we were talking about? All right, that made sense, hopefully. Yes? I'll take your silence as yes. You guys can hear me, right? I don't know why. It's getting a little laggy on the voice recognition there. But hopefully that made sense. Hopefully we're in the clear. But if it didn't, again, just speak up and let me know. Now we can go ahead and convert. Find our LCD. All right, we good? I'm happy to hear that. Excellent. Trying to find our least common denominator, we need a factor of, here I have a factor of x minus 1, a factor of x minus 1, and a factor of x. To satisfy everything, I need a factor of x to make this happy and this happy. And I need a factor of x minus 1 to make that happy and that happy. So I need x times x minus 1. Okay? Now I can convert everything to be out of that least common denominator. I have x times x minus 1 here. Well, that's what I'd like to get. I'd like to get x times x minus 1 here, and I'd like to get x times x minus 1 here. What do I need to multiply this by in order to get this? Well, what's missing is this additional x at the beginning, so I need to do 5 times that additional x on the numerator, because the 5's already there. What do I need to multiply this by in order to get this? Nothing at all. It already is equal to that, so we'll just leave it alone. That's just a 1, carries down. What do I need to multiply this by to get this? The missing piece is this x minus 1. So I need to take the 3 that's already there, multiply by x minus 1. Okay? Now that the denominators all match, we can just shift our attention to the numerator and say that 5x should equal 1 plus 3x minus 3. A little distributing right there. And once again, we've arrived in Algebra 1 territory now. I can just subtract 3x from both sides and combine like terms on the right. That gives me 2x equals negative 2, and so therefore x is negative 1. Negative 1 half. No, negative, cheapers. Holy cow, that's embarrassing. X is negative 1. Write that. There we go. How do I know that negative 1 is not extraneous? I look back up here. I say, is that 0? Nope. Is it 1? Nope. We're fine. We're fine. Okay? 2 more problems to go. Any questions while I'm writing this one down? Doesn't seem like it. Doesn't seem like it. All right, let's keep rolling then. Same kind of deal as up here. Very similar style of problem where you'd see a little bit of factoring to do in the denominator first. X squared should draw your eye to this term right here. And we could take out a greatest common factor of x from that. So if I have this problem, we can rewrite it now as x plus 5 over x equals 1 over x minus 5 plus 5 over, pull out a factor of x times x minus 5. Just like that. Okay. Let's identify our domain restrictions. Here we would notice that x could not equal 0 again. It's a common one, comes up a lot, because 0 in the denominator would be bad. And also notice that x could not equal 5. Do you see that? Because 5 minus 5 would also be 0. And this just has both of them. Again, to emphasize, we're only looking at the denominators to see what value of x would cause those restrictions. This numerator, x plus 5, like saying that x cannot equal negative 5 would be not accurate because the numerator can be 0. That doesn't cause any issues. It's when the denominator is 0 that we run into problems. So now that we identified that, I can go ahead and find my least common denominator. My least common denominator is x times x minus 5. We need a factor of x to make this happy, and we have a factor of x minus 5 to make those happy. It's very similar to the problem right above it. Let's convert everything to be out of that least common denominator. Equals x times x minus 5 here. And I'd like to get x times x minus 5 here. What do I need to multiply this denominator by in order to get this? Well, the missing piece is x minus 5. So I need to take the x plus 5 that's already in the numerator and multiply it by x minus 5. Going to do a little distributing there. What do I need to do to this to get this? I need to multiply it by the additional x. And what do I need to do to this to get this? Nothing. Okay. Continue this up here. Now the denominators match. We're just going to take a look at the numerators. So little distributing here, I'm going to get x squared. Notice it's going to be minus 5x plus 5x minus 25. So x squared minus 25 equals x plus 5. When you see that value of x squared showing up, that should be an immediate indicator that we need to factor. Okay, so before we factor, of course, we need to set equal to 0. So we're going to do exactly that. I'm going to move the x over here. I'm going to move the 5 over here. We're going to get x squared minus x minus 30. That's negative 25 minus 5 is equal to 0. How do we break that down? Well, we got to break that down to two binomials. I need x times x to multiply to x squared. I need different signs to make the negative on the end, 1 plus, 1 minus. And factors of 30 that'll combine when I distribute to this negative 1. I think it's negative 6 and positive 5. And so I get two solutions here for my problem of x equals negative 5, because negative 5 plus 5 would equal 0, and x equals positive 6. And notice that neither of those match my restrictions. This one's close, but our restriction was positive 5. This one's negative 5. We're happy with that, no problem. And 6 obviously works out too. Question about that before we head into the final problem of the day. Alrighty, I need another piece of paper, and then we'll do one last problem. Get a fresh sheet of paper. All right, here we go. Last problem. Ready? This is the toughest one. We got 1 minus. So already you see that value of 1. Just gonna make sure remember it has a denominator of 1. X plus 3 over x squared plus 2x minus 8 equals 1 over x squared plus 2x minus 8. Okay? Let's see if we can solve this equation for x. It goes without saying, your eyes should be immediately drawn to that factor, factor, factor. Absolutely. I'm going to have 1. I'm going to rewrite my 1 as 1 over 1 just to make it a little more comfortable so we see that denominator showing up. Minus x plus 3 on top is already there. How do I break down x squared plus 2x minus 8? We need x and x. We need 1 plus 1 minus, and I'm going to need plus 4 minus 2 is equal to 1 over x plus 4 and x minus 2. Notice that factors down the same way because it's the exact same expression. My domain restrictions here, I would notice that 0 is actually not one of them this time. I would say, well, x cannot equal negative 4 because notice that negative 4 plus 4 would result in dividing by 0. That would be very bad. And x could also not equal 2 because 2 minus 2 would equal 0. And again, bad news. All right, it's just like finding those vertical asymptotes, looking for what value of x in the denominator results in dividing by 0. Okie doke. All right, now we can go forward and we could say, well, our least common denominator, I think this LCD is pretty easy to see. We clearly need x plus 4, and we clearly need x minus 2. Right? There's nothing else to really even consider besides this factor of 1, but 1 times anything is itself, so we don't have to worry about that. I would like to now convert everything, it's going to be a lot of writing, to be x plus 4 times x minus 2. Same thing over here. I'd like to convert the second term to be x plus 4, x minus 2, and convert that third term to be x plus 4 times x minus 2. What do I need to multiply this by in order to get this? Well, I need to multiply it by the whole thing because none of it is there at all. So that's going to be the whole expression of x plus 4 times x minus 2. The others, though, I don't need to change at all. These are already the same. So I'm just going to leave this x plus 3 here, and I'm going to leave this y. Okay? A little bit of trickiness in this problem that I wanted to point out is this negative out here. Okay? Keep in mind, it's a very common mistake and it's very tempting to do, is just write this as negative x plus 3. But this negative 1 is going to distribute to this x and this 3. So keep that in mind. When you see a negative sign outside of a fraction like that, it does distribute to each term in the numerator. Okay, that's why this problem's a little tricky. I don't know if that distributing is necessarily featured on your PA, but I wanted to point that out to you today to just show you that that negative would distribute here and here. So we're going to do, speaking of distributing, we're going to multiply this out, the x plus 4 times x plus x minus 2, which, by the way, we already know is equal to this because that's how we factored it. So we can just say that that's x squared plus 2x minus 8, distributing that negative minus x minus 3. Again, it's like saying negative 1 times x and negative 1 times 3 is equal to 1. Now that I see that x squared show up, factor, factor, factor. Let's do it. We got to set equal to 0 and combine like terms. I got x squared plus x. That's 2x minus 1x. I have negative 8 minus 3 is negative 11. We're going to subtract the additional 1 while we bring it over. That's going to be minus 12. We can break that down now to factor. It should be pretty fast at this point. X and X, 1 plus, 1 minus, looks like plus 4 and minus 3. That gives us two solutions of X equals negative 4 and X equals positive 3. I could already see the look in your eyes. I could picture it. I could picture it as if I was standing face to face with you. Yes, X equals negative 4, bad news. It matches our domain restriction, right? We can't have this because we already said at the top, X could not possibly equal negative 4. So that means this solution would be extraneous. And we'd have one real solution, though, of X equals 3. Okay. So again, that's why it's worth it to take the 2 seconds and just identify what our extraneous solution is going to be, because see how fast that check was? We didn't have to plug it back in and go through all these hoops. Okay. Any questions, comments, or concerns about that? Alrighty, everyone. Thank you so much for your attention and focus today. You will be receiving a progress assessment via email again. It will be due again Sunday night, 11:59 p.m. Please make sure you get it done. It's only 4 questions, so it shouldn't take very long. You could ask me any questions if you have any questions, or reach out to me with any other concerns. Thank you, everyone, for your attention and focus. Have a great weekend. I will see you on Tuesdays the next time I see you. So enjoy, adios, and have a great day.